Recording. Okay, can we continue? It's a 3D space, right? A, B, C. That is sounds like the plane, right? Equation for plane. That's fine. That's fine. Show that equation of P. So this is a question, right? This is a special question. You want to show that the equation of P, because 3.123 are point on the plane. So this point on the plane P, or P just is a P for plane, right? P for plane. And found that equation is as simple as that. You probably can start with just draw this diagram, give you some idea where are these 3 points. Can we just draw this roughly? Where are these X, Y, Z? What is X equal to 5, right? Is X, X, Y, Z. So 1 is a 4, 1, -2. 1, oh. So this satisfies the condition, right? 1, 2, 3, 4, 5, 4, 5. First question is y equal to 1, y equal to 1, z equal to -2. Oops. Let's just to the -z. So this is 1, so 1 is -2, 1, 2 is -2.
It's -1.
Like y equal to 1,
right.
-2, right? So, well, this is just one of them. Can you see? It's 4. That's somewhere here. It's underneath. Hard to draw that. But doesn't matter. We don't. How about another? C is easy. C is z equal to 0, right? Y equal to 2, y equal to 4. So 1, 2, 3, 4. So the C is easy. So this point C is here, and so this is A, point A. And how about the B? B is 5, and y -4 and -1. Oh, wow. Some here -4. No. Z equal to -4. Z equal to -4 somewhere here. Z equal to -4, and y, so y x equal to y, z equal to -4, and y is -1. Oh, so this is y. So somewhere here, can you see? So that's B, A, B, C. Wow. That's roughly where these 3 points are. And these are on the plane. So if they're on the plane, they must be satisfied some equation, right?
Yeah.
So basically this is Z, right? This is Z. Oh, you just substitute by substitution, isn't it? Just by substitution to see this, if this is 1 by 1, if these 3 points are indeed satisfy this equation. Can you do that? It's just to check, isn't it? There's no derivation. You just say, well, if these 3 points are on this plane, then the plane can be written as this equation. So just simply try it. Okay. Yeah, you just found the sum. You found the sum to say if that equal to 12. The 12? Okay, that's for this point A, right?
Yeah.
Yeah, just do it 1 by 1. This question is not challenging at all. Okay. Yeah, that became challenging if they ask you to do this, you know, the angle between two plane, and this became challenging. That's right. But done, right?
Mhm.
The first question is simple, okay? How about second one? Learning question, plane question.
And then
Ah, that's part A, right? Part A.
Mhm.
Okay. Normal to B, that's right. So from you have to work out the, what is the direction. So if you have plane, how do we work out their unit direction? It's called n. Did you use n, small n?
Mhm.
So you need to find another equation normal to this P1. Okay, so normal means there's two. This is do we call this through the point, through this point? Oh yes, you have not just found the equation. You must also satisfy this condition. I mean, there is a constant. So because this Sn is determined by three numbers. Do you use this notation? ABC? Do you use this notation for your unit vector?
Yeah.
You have divided, because one, you have divided square root, right?
Mhm.
A squared, do you use this formula? B squared and C squared. So therefore, the unit is the length of this, this called the unit directional. Did you call that? It's called the unit directional vector of this plane. Directional vector. So the unit means that the amplitude is 1, all right? Now, the question is, how can we find this ABC from this equation? So in this equation, this is P, right? The first plane, 2y. Can you put a coefficient here? 1 multiply z, right? Now from this equation, how can we work out the directional vector n? Do you know what I mean? That's right. -1 or +1?
-1.
Oh yes, you are right. I should put negative here. Okay. So this is vector, and another plane. Can we use a different color? Another plane is perpendicular to that. Is that perpendicular? Normal. Yeah, it is perpendicular. Another plane is this one, like this one. Can you see? So just use this blue color, a different color. So the blue one, the directional vector is goes that direction. Can you see? Can we call this as NP? Another plane is a Q. Can you see? That's NQ. All right. Find the equation normal to Py because this plane point to P. Okay. Okay. So this is NP. So how can we work out another one? How will work out another direction? Yes, that is a directional vector for the first plane, the plane P. So that is a directional. So we know this one. You see, it's this white color. But we know that yeah, you have used a condition how to work out because they are perpendicular. So n, so these two vectors are perpendicular. So how can we solve this puzzle? So these two vectors are perpendicular. This NP. This is NQ. So the dot product must be equal to
0.
0, right? Yeah.
Isn't that what we did here?
No. Actually, I think I check your formula. We don't have to normalize that. We just because there's constant to be determined, right? So basically, you can this is called ABC, right?
Yeah.
Can we call this unknown is ABC rather? Can we call this one? Because we got one this one. Can we this is our known directional vector, right? Can we call the other? Can we call this Q? Is determined by 3 unknown constant ABC. Because ABC is unknown, right? And given these two vectors are normal to each other, so what would be their dot product? What is the dot product? They are normal. They are perpendicular to each other. What's normal? What is
0.
It is 0, okay. And now can you use this? Yeah, you use this condition now. Why did you choose this 3, 1,
Because
negative 1?
that's the point.
We need to find the vector, which is can we just find this? Can we start from here? I just realized, can we just, this is pretty simpler, just go from this one. We don't have normalize that to unit. Can we just from here first, all right? We need to find the vector which is normal to that. So how can we find the direction? So can we use this, can we draw some graph first? So this is 3D graph. So in your case, this directional vector, not normalized, not unit. So x equal to 2, can you see? X equal to 2, and y also equal to 2, can you see? Y, this 1, 2, this y also 2, and y, and z equal to negative 1. So it's somewhere here. Oh, it's difficult to draw that. Roughly, so this is n, can you see? If I draw that, there's a graph here. So that's the as direction of n, can you see? Now, this is, I just ask you, do you think you can solve this this ABC by under this condition? We only have one equation, right?
No.
It's XYZ, can you see this XYZ? We know in these two plane are perpendicular. So in other words,
wait, yes, can.
if they are perpendicular, we have the dot product equal to 0, right? But that, I wonder if just one equation, can we solve the 2, 3 constants? You know what? Do you know what I mean? We need to write up another equation whose directional vector is perpendicular to the first one.
It could be
Can we just write this equation to see how far can we go? If we just use this dot product, which is one is I just read this one, 2 to -1, right? Do you use this notation A, B, C? So that will equal to 2A plus 2B take C must be equal to 0. That's represented dot product, right?
Mm-hmm.
Is that enough to, can we solve the A, B, C?
Yeah. A equals -1.
Oh, how did you do? You just guess, right?
Mm-hmm.
Oh, it's interesting. Yeah, you found it. Okay. Now,
Yeah.
if you know ABC, then you should be able to write the plane now. Can you see?
Mm-hmm.
So this is a new, this ABC will represent this. So this basically this N. So this P is can you see? Basically, you can, based on this information, you can write. If you do you know how to build the equation? Oh, sorry, it's not transparent. Can you see? If we can find ABC, then we can use this A. This is A. Can you see? This is B. This is C to build another equation with unknown constant, which can be determined by that condition. Do you know what I mean?
Mm-hmm.
So basically, this just you see, because when you're talking about direction, then they just like talk about similar triangle, right?
Yeah.
So they could, you could have another, you got a multiple of this number, right?
Mm-hmm.
But of course, you choose to make the question simple, use a smallest number. Okay.
Yeah.
Now, therefore, this is the question for the plane. Do you remember? Equation for the plane. In general, if you remember, that is AX plus BY, right?
Mm-hmm.
Plus CZ equal to D, all right? So we know
Yeah.
ABC, so we can write this equation now. Do you agree?
Mm-hmm.
So this is the equation which is perpendicular to the first one, except we don't know D, right? We don't know this constant. Can you write it down?
Oh, we can figure out the constant though.
Because they give the number here. Can you see?
Mm-hmm.
Okay.
Mm.
Yep. So the sum will be your constant D. Aha, we got everything.
Yeah.
We got ABC, we got D. That's it. So that you can write your answer now here. That is the equation we are looking for.
Mm-hmm.
Can you write your equation here finally in this space? That's right. That's it. So that is the question we're looking for, which is perpendicular to the first one. Yes. Okay, let's go to next question. Yeah, playing in the 3D space. Aha,
Oh, this is question C.
Okay. Oh, it continues. Yeah.
Mm-hmm.
Normal to P1. The first one is P1, right?
Yeah.
Intersect P2 at the point E. Find the coordinate. of E. The normal, what do you mean the normal? The normal to E1 through
The one that we calculated, which is negative.
Aha, this question, right. This is third plane, right? This is third plane?
Mm-hmm.
Or second one? Is the same as the first one? No, no, it's not. It's another one. It's third one.
Yeah.
Got third plane. Wow. Normal to P1 through. Is this D? Is this D? Capital. Is this D? A B C D E. Is it A B C D E?
Yeah.
I
So
guess.
this is the one that we calculated, and this is this.
Okay. Normal. Can you draw the graph? Find the coordinate of E. Yeah, that is X, Y, Z. Yeah. You put Z upward. This coordinate right hand row is X, Y, Z. It's up. It's according to right hand. So you need to find the three numbers, right? In order to determine the point in this plane or intersection.
Yeah.
How many plane intersect? 3 plane, right? So we got roughly, can we say we have in this space, I can draw elsewhere. So we have one, we just work out what we're trying to do, and then we use algebra, okay? So we got this one plane here, and secondly, we got another one, which is perpendicular to this one. Do it again. That's good. It's good to know what we are doing. So basically, the another one is perpendicular, right? Another one is perpendicular to this one. So their intersection will be a straight line, right? Then now you got the third one coming. If I use different colors, so this third one could be we don't know, and like this, can you see?
Yeah.
So it could be any direction. So these 3 plane must have intersection, can you see? So they must have a solution, isn't it? At somewhere. This is E, isn't it? Can we call this E? So this E must be satisfied these 3 equations. Do you agree?
Yeah.
Because so can we just write it? We just treat this as our linear function. See, this is use the graph can help you to understand what you are doing. Let's just go to first one. So first one is 2, 2, negative 1, 12 is 2, 2, negative 1, 12, right? And do you remember the second one we just worked out? X, Y, Z. Can you see? Do you remember? Yeah, the second one is negative 1, 2, 2, negative 9. Okay. So negative X, 2, 2, Z, negative 9. Now we have put a third one here. Third one is 2X. Oh, this one is parallel to this another one. Can you see? Can you see the similarity? These 2 are parallel, except they are parallel. These 2 planes are parallel to each other. Can you see?
Yeah.
So these 2 are parallel. So if I draw that correctly, can we just redraw that? Just take some time, because if you know the graphical meaning, then you can easily solve this one. Can we just Can we just get rid of this this one? We know it is parallel to the first one. Can you see? We know it's parallel to the first one. So why don't we draw a plane parallel to the first one? The blue one is we just obtained, right? Now the question is, if you draw another one which is parallel, can you draw? If I draw the parallel to the first one, that's strange, isn't it? How can we accept the fact they don't have the? I don't think they will have intersection of these three planes, right?
Oh, it doesn't have to be the 3 planes. It just has to be 2.
No, do you know what I'm trying to do? This is our P1, right? Plane 1. Sorry, this is P1. This is plane 2. This is plane 3, right?
This is the normal.
Which is this is normal? Yes, that's right. These are P. The green one is P2. All right. The white one is P1. Okay.
Yeah.
And the red one is P3. Now you tell me. Do you think they have solution at one point? I don't think so. If the two planes are parallel, this is a simultaneous equation, isn't it? This is a simultaneous equation. 3 unknown linear equation. So if we, because these two equations are the same, so how can we find this? There's not of the solution, not just one solution. Do you remember do you remember we discussed this type of question before? There are either have no solution or have infinity number of solution. Do you remember that when we're dealing with simultaneous equation, linear simultaneous equation? Graphically means that if they have no, if I want, because these two are parallel, can you see? Parallel. So if I can we just write that into the matrix form, right? So that -1, 2, 2. You see, if you have this -1, 2 to -1, so I don't think we can solve this unique XYZ, sorry. Can we find the inverse? Do you know how to find the inverse of this? So this matrix, can you find the inverse? So this is A, 3 by 3. Or you can use a Gaussian, you know that the row reduction. Do you remember the Gaussian law reduction? So I think in this case, we only have 2 independent equations because you can see these two are the same. Can you read the question? What they are looking for? Find the coordinate of E, which means X, Y, Z, right? X, Y, Z, and intersect. They got 3 points, right? See, so normal to P1. I'm not quite following this question C. Can you tell me, if we go back to the first question?
This is the normal to P1.
Tell me, yes.
This is the normal to P1.
I know. The green one, yes. In the picture, in the green one. Can you see the picture? The green one. Yeah. The third one which we just get is this plane is parallel to the first one. Do you agree? So they are also perpendicular to the green one. Do you agree?
Yeah.
The third one. So this is the third one. So the third one so also is parallel to the P1, right? Parallel to P1. I just wondered if we got the question correct. If, for example, in general, I can tell you, if that these two parallel, if this third one are not parallel to any of them, then in principle, we should find unique solution. right? Otherwise, I don't think you can find a solution. Just use this graph that will tell you you cannot find the point which satisfies three equations.
But it doesn't have to satisfy 3. It just has to satisfy this one. Just the intersection of P2 and P3.
Where is P2?
P2 is the green one.
Yep.
And we just need to find where that meets.
With what? With the third one? With
no, just P2 and P3. Where do P2 and P3 equal?
Oh, forget about P1, right?
Mm-hmm.
Forget about P1. But that solution will be a straight line, isn't it? Yeah. Because if you only have two independent equations, then the number of z is one of them is infinity. Do you agree? Mm-hmm. I can tell you, I can use this graph just as a purple color to tell you if you are looking for the solution P2 and P3, then their solution will be here. Oh, did you use blue one? Yeah, that's right. Can you see? Mm-hmm. That is their solution. It go on forever. Can you see? It's a straight line. The solution will be a straight line. Can you see that? Every point on this purple line is a solution. Mm-hmm. So there's an infinity number of them. Do you want to try to solve that? Can we see? In other words, we are solving this equation. Can you see? The third one is undefined. So we got 2x. No, use the first one. Use the second one. We just pick up 2. Can you see? Mm-hmm. We just use 2. -1, -1, 2, 2, and 2, 2, and -1, right? And this is 0. Can you see? We can just use this equation to solve this one. X, Y, Z, right? Mm-hmm. And this is 2 by 2 because Z can be any number. Can you follow me? Yeah. That's -9. That is -15. So Z could be any number, isn't it? Mm-hmm. So in other words, we need to find the X and Y. That's all. Relation between X and Y. Z can be any number. Does that make sense or not? Yeah. Because the solution will be a straight line. We can.
I can look at the answers.
You look for the answer first. This question you have to really understand what they're asking. If they found the coordinates, then that means that they are looking for one point. Okay. They would expect the solution is for E is just determined by 3 numbers, X, Y, Z. But from the graph, the solution is a straight line.
So to get the normal, they did it 3, 1.
Oh, that is a normal. This is straight line, right? This is straight line. Normal straight line. Yes.
And so they know that X equals.
Yeah, that's parametrical equation. You introduce a T. Okay.
Yeah, and then they just subbed these into this equation.
Oh, so this time they not just found the normal direction, but actually they found a straight line equation, right? So this is a typical equation. This is slope. This is slope, isn't it? This is slope. That is just y. So that is y equal to this. So they can work out this. So n is x, y, z, right?
Yeah.
The n is determined x, y, z. So this question is a combination of the equation for a plane and equation for a straight line. So how did they choose a t?
Oh, t is this one. It's just a constant.
Yeah, t is just any number between 0 and infinity, right?
Yeah.
All right, so that is how they didn't solve the simultaneous equation. So what
No,
is
then they send it
what
in
is it?
the
Yeah, so
t.
can we use a graph to indicate their solution? So this is a straight line, and this is their slope, right? So that got a straight line equation. So x slope is 2, y slope is 2, and z slope is -1, right? This is 4, right? Is this 4? -1. So -1. So they found the normal direction of normal straight line, right?
Yeah, and then
so that is the coordinate they're given. So these 3, 1, -4 is given by this equation, right? Let me see. This is this 3 number. Can you see? Can you see this 3 number? 3, 1, -4. That is because what they do is they just say that they for straight line. So we basically they just say that the x can be written as a straight line. Do you know that? Do you remember the straight line vector equation? That is r is equal to a, the vector a plus k, which and b, right? They use this equation. So basically they are using this equation, can you see? And this r is basically x, y, z, can you see? X, y, z, determine x, y, z, okay? And a is that special point they given in the previous question, can you see? And the slope they obtained is this one. So the slope, this is k, right? K is constant. So k is constant, isn't it? Use t, they use k, it doesn't matter. So basically b will determined by that condition, which is perpendicular to the first one, right? Use a t, right? Use a t. So this 3 number is determined by the perpendicular condition we obtained on the page 1, right?
Yeah.
So that is a number we obtained. -1, +2, +2. That's that different. Did you use this 2 to 1, 2 to -1?
No, they just use the point on the plane and then t times that plane.
Yeah, I think these 3 number you used is a 2 to 1, 2 to -1, which is this 3 number, right? Do you remember the first plane? 2 to -1. Did you use 2 to -1? That will represent the straight line normal to the first plane. Do you agree? Normal to the first plane. Oh, that matters. So you as long as you get familiar with the equation for or a line, straight line, that is formula. That is a vector form, and also if you get familiar with this the plane. So the plane, can we write down the equation here for the plane? So that is this for the straight line equation. Oh, sorry. Okay. This is 9, and the plane is you can use the similar notation. That's at w equal to two vectors. You have used 2 vectors. Can you see? You have used two a parameter here plus L. That's my. So you can. This is the question vector form for the plane, right? We use this. We use there several times, but this can also written into x, y components because r can be written as x and y, z. You see, x, y, z. So that is why in other words, each vector equation can be written as 3 components equations for x and y, z. Okay. All right. Can we? Any other question we can discuss?
Then it says to find the distance between P1 and P2.
Or the distance, that coordinate. They found the
That's
distance.
Question.
Well, if where is the next question is from the distance, right? Well, distance is just use Pythagoras law, right?
Yeah,
You have
distance between two planes.
2 points. Yeah, 2 points. You just use Pythagoras law. You see, you got their coordinate here. You got coordinate here. For example, they got coordinate here. So just Pythagoras law. Because we know the formula for the in a 2-dimensional, right? In a 2-dimensional, that is just so if you have 2 positions, you just find this. You have the if you have this 1, 2, 3, right? 2 point, put 2 position, 2 position. So you just found their x component, you see, and should I say, can we just go to two-dimensional? 2-dimensional is simple. You got this 1, 2, right?
Yeah.
You just the distance formula, you know that it's just root, you see, square root, Pythagoras, and x1 takes x2, right? And that is square plus and y1 take y2 square. So if you extend it to this 3rd dimension, that would be just z1 take z2. That is formula for distance, isn't it? We know the 2 point. One is p, one is q, right? We got x1, y1, and z1. Do you know what I mean? x2, y2. We know this 3 point already. Do we know that?
This is the distance between points. What about planes?
Oh, that's different. Yeah, that's right.
Yeah.
Then you have found the shortest one. That's good question. You have found the shortest distance given a plane. Okay, that's right. You basically have looking for the normal direction. Can you see? We just use this graph here. So if you have the plane, look next plane. So if you have this is a straight line. You have a straight line, right? You have a straight line. Sorry. You have a straight line. You find the distance at a certain point, right?
Yeah.
Then you have
No,
found
it's 2 planes. Yeah.
2 plane, not 2 or 2 planes. So not parallel. The 2 plane not parallel. Are they parallel?
Yes, because P1 and P2 are parallel.
Oh, they are parallel. So they found the distance given 1 point, right? Are they looking for this distance?
Yeah. Without a point, we just have to. We know the planes.
Yeah.
P1.
Yeah, that is a plane equation to find the distance between these two, right? Yeah, I think you have to build the vector, right? These 2 plane, and what is P, what is Q? One is called P, another is called Q. The found distance, or what is the question?
Find the distance between these 2 planes, P1 and P2.
Between 2 points or between 2 planes?
2 planes.
Ah, they are parallel. So these 2 planes are parallel, isn't it?
Mm-hmm.
Ah, okay. So that is yeah. So I think that will come from this number, isn't it?
Mm-hmm.
It's let's how do we find the distance between these two? These 2 planes are parallel, right? These 2 planes are parallel. Their vector direction is parallel, but they are not in the same plane, right? They are not in the same plane. So what we can argue? And the distance between these two. Can we just assume this is XYZ, X1? They must be satisfied this same equation, isn't it?
Mm-hmm.
If I don't invoke the vector, can we just call this X1, Y1, Z1, right? Z1. So this is X2, Y2, and Z2, right?
Mm-hmm.
And the distance, they must be set. So how do we simplify this? So they must be set these two, this straight line. So this straight line must be perpendicular, how to say, parallel. Can you see? How can we write the straight line across these two? Can you work out a straight line? Are you able to build an equation which pass perpendicular to this plane?
Yeah, we did that one, which is
Yeah, can you write down? Okay, okay. And this n is just xyz, isn't it?
mm-hmm.
So this vector is actually just xyz. Do you agree?
Yeah.
Or probably use this this called the vector sorry, matrix form. 3, x1, 4. So that's parametrical equation, right? T can be considered as time or just any parameter. 2, 1. Yes. So we need to find the distance. And well, we have to work out the different well, I forgot how to do that. It must be very straightforward, isn't it? The straight line here, and can we invoke the 2xyz? Can we find the difference between these two? I still wondering if we can use this formula, knowing that xyz satisfies this
a different formula for planes?
For plane.
Mm-hmm.
Let me see. Different plane. I don't know. If that is because we're just looking for the distance. If you don't use distance formula, we got xyz, and this xyz. No, I don't know how to solve this puzzle. I think you have to Cartesian form. The plane have the Cartesian form, which is you can determine distance. How can we figure out this? We got everything we need. We got the straight line function. We got line function here, which is which can connect the two plane. And presumably the XYZ can satisfy one XYZ satisfies first equation. Another XYZ satisfies the second equation. The question is, how can we find the distance between these two? If this XYZ is confined to this plane, the distance this is a parametrical equation. If T is can we just use a T? If you choose T equal to 0, if we can we do this way? Can we do something about the T, right? If I just assume if T equal to 0, the point is exactly on the one plane, right? So how can we work out another XYZ? How can we determine the T? The matter became how to determine the T, isn't it?
Yeah.
So this if we just by choosing the T equal to 0, and the one point will be 3. That will be the first point. Can you see? How can we adjust? Yeah, it's just probably just single trick we can do. If we choose T equal to 0, when point is equal to P, what would be the Q? What would be the T for when there's a straight line, when this point arrived another plane?
Oh, we calculated the T, didn't we?
Can we calculate the T from the equation? Ah, you got
we did it from the last equation.
Yes, right. I can just check the three. Oh, this three equation, right? So when T equal to 1, we can obtain a group of XYZ. Can we just use your notation here? Hopefully we can make some argument. So basically when T equal to 0, what is XYZ? So we could choose x1, x2, sorry, y1, x1, y1, z1 equal to just the first 3 numbers, right? 3, 1, -4. Now, how can we find another T? That's the same question. We don't know
we can calculate T by putting these ones into this formula.
You can try. Can you show me? How can we determine another value T? Oh, you substitute that, satisfies that equation. Oh, I see. Oh, any plane or the second, a third one, the third plane to satisfy T, right? Oh, yes. So if we can solve the T, then we can solve another XYZ, right? If you find another XYZ, then we can use distance formula. Can you solve the T from this single equation? Because in principle, we should be able to find the T, right? That's right. That's right. I think that makes sense. We can assume that when T equal to 1, the straight line is intersect with one plane, okay? And then we force this, we assume at the time T, the point will satisfy the second parallel plane, right?
Yeah.
Okay, oh, that's right, we solved the problem. Ah, the t solved, the fraction. Oh, it's divisible, equal to negative 3. Oh, doesn't matter, it's just velocity go backward, right? Okay, I think that is good. So we should be able to find another point. Can you see? By using this formula, we can find another set of x. Can you see x2, y2, and z2? You see? That in this case, we can use, you can use the parametric equation. Can you see? That is the 3 plus 2 multiplied -3. Can you see? And so on. And then we have to use, finally, we have to use this distance formula. Do you agree? We have to use this distance formula. Once we got x, y, z for 2 points on these 2 planes, we still have to use this distance formula. Do you agree? Yeah, it's solved, isn't it? Can you follow me? So we just we found the first x, y, z, and then by solve the t, we found another x, y, z. These two x, y, z can be directly substituted into this formula for the two distance, for the distance between the two in the 3D space. Can you follow me? Solved. Do you agree? Are you convinced? Solved this question? Not quite.
I'm not sure.
Well, I think this question solved. You see, basically what we did is that we just net the x, y, z. We choose t to 0. We obtain 1 point because that t is a parameter. Okay, the starting point of t can be anywhere, right? Just you can use for example, if you can use a stopwatch. You can zero stopwatch at any time. Do you agree?
Yeah.
You don't have to say, oh, this is 5 o'clock. You can say this is 0 o'clock, midnight. Can we? So the t you are entitled to choose a t. Okay. When you choose a t to 0, the three number will give you the first point, which is on one of the plane. We don't want to use this. This would be the position of this of the first plane. First, let's just do this one. Solved. I think it's solved. Can you see that? We have two parallel plane, and we know the straight line is parallel to perpendicular to both. Can you see? But this P1, this P2, this P3, right? So when we assume this t to 0, so this is our time coordinate, okay? It's turned out t is negative, doesn't matter. So this t to 0, okay? Can you see its count? And then we count out, and eventually we solve the t. What is the t? T is to -3. Do you agree? So in this way, we found this p and q coordinate. Can you see?
Yeah.
So we solve the t, and eventually we have to use the distance formula. So can you see? We have used this distance formula. That's all.
Yeah.
It is solved. It is solved. Yeah, thanks to the parametric form of this normal directional straight line, which is very useful. Can you see this one? Actually, this one. Okay, let's see you next time now.
Yeah, I'll see you next week.
We'll save that. I'll send it to you. Okay. Goodbye.
Okay, thank you. Goodbye.
Yeah.